Okay, this is the notes for Unit 9, Day 3. I'm going to do some graphing of rational functions. You'll notice a lot of the stuff we've learned this year about graphing. Typically we have this shape we're supposed to memorize, and then we adjust it. We shift it up, down, left, right. We flip it over, and so on. So that's kind of what this one is going to be. So learning targets here, I can sketch the graph of an inverse or an inverse squared variation. Now, inverse function is also a reciprocal function, we call it, and that's what this guy is right here. And then the inverse squared is, what's going to be this guy right here, has an x squared in it. And then I can graph variations of these. So we're just basically going to shift them left and right and up and down. The table, I filled it out just for sake of time. I filled it out. If you were to plug in a -3 on bottom, 1 divided by -3 is -1/3, and so on. You see I filled out the chart. And notice 0, when I plug in 0 here, 1 divided by 0 is undefined. And if you are trying to get 0 for an answer, so if I took 1 divided by anything, could I get 0 for an answer? So notice 0 is not in here anywhere. I mean, this number is kind of, I think 3, 2, 1, it's getting smaller and smaller and smaller, but no matter what, no matter how big of a number I put in here, I can't get 0 for an answer. It's getting very close to 0, but I can't get there. So that's where some asymptotes are going to come in. So we got this undefined. When we plug in 0, we don't get an answer, so that means 0 is not in the range. Or in the domain, but also it's not in the range because it can't come out for an answer. So, so that kind of basically means this is thrown out as an x value. So if you quickly plot these, let's see if I go left 3 down a third, left 2 down a half, and you start getting, let's see, the shapes on left half down 2, and it kind of makes this curve in here. But notice it never equals 0. But also, when I plug in 0, I don't get an answer. So there's a vertical asymptote right here, okay, going this way, and there's a vertical asymptote going this way. Also, when I plug in 1/3, it's up 3. When I plug in a half, it's up 2, 1, and it's kind of going, so I plug in 1, so you plug in 2, it's at a half, and a third, so it's going like this. Okay, so it's kind of this shape like that. And so what we need to do is try to memorize that. If you can't memorize it, you can always make a table, but we'd like for you to memorize it, and then we're going to kind of shift that up, down, left, and right. So the domain, okay, so the red here, the domain here is, it's basically going to be all real numbers except x equals 0. Okay, so basically anything but 0, and the range is going to be all real numbers except y equals 0. And those create these vertical, so vertical asymptotes right here at x equals 0, and there's a horizontal asymptote at y equals 0. Okay, so that's for this function right here. Okay, now down here they want us to do for 1 over x squared. You're going to get kind of the same thing. Again, I'm going to speed things up here. If I plug in x, my y would be 1 over 9, 1 over 4, 1, 4, 9. If I took 1 over 0 squared, I get undefined again. 1 over 3 squared is 1/9. 1 over 2 squared is 1/4. 1, sorry, I think I messed up here. Yeah. So 1 over 3, this would be 9. I got these backwards. 4, and then this is going to be a 4th, and then a 9th. You notice they mirror each other here. Okay, so these answers, if I did them right, if I didn't try to do them too fast, they mirror each other. Okay, and notice there's no negatives over here. You can't get a negative answer because if I plug a number in and square it, it's going to become positive no matter what. So this graph is going to stay above the the y-axis, and so the range will have no negative answers. None of these y's are negative. I can plug negatives in, so that domain is still going to work, but the range is not. So for the domain on this guy, I can plug in anything except for 0. So all real numbers except x equals 0. For the range, this is basically any y greater than 0. Okay, and then so the vertical asymptotes, the horizontal asymptotes. There's a vertical asymptote right here, so x equals 0. There's a horizontal asymptote of y equals 0, and to kind of speed things up, it does this. Makes that shape. Okay, now those aren't the exact points. I could plot those points on there, but just to save some time. So it kind of makes a volcano graph. Okay, it makes a volcano graph, whereas these mirror this way, these mirror that way. Okay, and the shortcut for these, again, that's supposed to be a negative right there. This is kind of the standard form here, where the H is right here. That says left or right, so left or right. It's going to shift it left or right, and that is the opposite of what you think. So if it's negative, it goes right. If it's positive, it goes left. The K, we'll do this. So then the K's have to do with up or down. So if you have a K on the end, that's going to shift the whole graph up or down. And then the A's are, if it's a positive, nothing really happens. It changes how deep into the pocket or how shallow it is. I'm not really concerned about that so much, but if it is negative, it flips it. So if A is negative, it's going to be a flip. If A is a positive, it's going to stay like this, like the parent functions. Okay, so try to remember that one on the back here. If at any point you just want to pause it and kind of practice yourself, that's great. I mean, definitely pause this and as much as you need. I'm going to go. I might not do all these because we're up to 6-7 minutes already. But this graph right here, it's going to go 5 to the right. So I'm gonna my vertical asymptote's over here now instead. It didn't go up or down at all, so this is still here. Okay, and the parent function is 1 over x, which is this shape. I'm not really concerned about exact points. Don't worry about hitting the perfect points in there. Just the general idea, the general shape. Okay. This guy here, I've got 3 units up, and notice this is negative, so that's a flip. Okay, so the parent function is 1 over x. It's going to be 3 units up, so the horizontal asymptote is here at 3. And I'm skipping the information here. I mean, domain, as long as x does not equal 0, the range, 5. And then the range is y not equal 0. Everything else works. The vertical asymptote is at x equals 5. The horizontal asymptote is at y equals 0. Okay, so just kind of, I'm going to skip that step. I think it's just where the asymptotes are. So hopefully you can practice that in the homework. If you have trouble, you can ask me. But so this is the horizontal goes up 3. The vertical didn't move, so it's still right here. And now that flip means instead of the upper right corner and lower left corner, it's going to be upper left, lower right. Okay, it's going to be that shape. So that's kind of the shortcut. Okay, we can throw 2 shifts in one. Okay, so this is left 3, this is down 2. So left 3, 1, 2, 3. Here's my vertical asymptote. Down 2. Here's my horizontal asymptote. Okay, and then no shift. No flip. So it's going to be upper right and lower left. Notice it crosses the x-axis here. I think a lot of students, they end up keeping it above the x-axis, but it goes down. It's going to get really close to this horizontal asymptote. Okay, so yeah, and then I might pick just 1 or 2 of these guys just to save time, but just be careful here. This is a squared. Okay, so that's the volcano graph, but it's down 4 units. So down 4. So I'm going to go 1, 2, 3, 4. And then this didn't move, the vertical. And again, it's a volcano graph because it's a squared, so it's going to look like this. Okay, now I could fill out my domain. My domain is all real numbers except x equals 0. That's kind of how I think MathXL wants you to say it. If you notice above here, I just put all x is not equal to 5. You could put not equal to 0, but that's kind of how MathXL wants it. The range would be all the y's greater than -4, because just everything above -4 works. Vertical asymptote x equals 0, horizontal asymptote y equals -4. So maybe I'll do this one. So this is a shift 4 left. So 1, 2, 3, 4. Didn't go up or down at all. So here's my horizontal asymptote still. And then it's flipped. So it's going to be flipped over. So it was a volcano graph. Now the volcano got flipped over. So it looks like this. Okay. So that's, again, just general shape. None of these points are exact. Just a real general shape of it. And then let's just say, maybe I'll do letter G, and then we'll get down to the bottom. So this is 3 down, this is 5 right, and that negative means flip it. So I got things going on here. So I think of those crosshairs that were at 0, 0, now it's going to be 3 down, 1, 2, 3, there's my horizontal asymptote at y equals -3, 5 to the right. So now I got a vertical asymptote at 5, and it's flipped. And notice it was an x squared, so it was a volcano graph. Now the volcano gets flipped upside down, so it looks something like this. Okay, and that's supposed to be arrows on the ends. So yeah, so hopefully that kind of helps. I'll kind of skip these two just for the sake of time. The last two questions now says write an equation that is of this for these, for A and B, with the following asymptotes. So let's say if I want to have an asymptote of x equals 6 and y equals 0, that means this was shifted 6 to the right, but not up or down. So it'd be y equals 1 over. If I want to go 6 to the right, I would subtract 6. If I want to shift it up 0, put nothing on the end. Okay, and it has a 1, so I put a 1 there. I'll do this one. I'll do part B with this. So y equals 1 over. Okay, so if it was 3 to the left, that means x plus 3, and if it's 2 up, plus 2. Okay, so that'd be the equation. Now if I'm supposed to repeat with this function, I got y equals -3 on top, and now if I went 6 to the right, it's going to be x minus 6 squared. So you got to put it inside the squared, and then none up, so plus 0. And on this guy over here, y equals -3 over, and it has an x-intercept -3. That means it went 3 to the left, so I would have x plus 3 squared. And then this went 2 up, so I put a plus 2 on the end. Okay, so those would be the equations with those asymptotes. So that was really fast. So if you needed to go back, do that and pause it, watch it carefully. Any point you got stuck, just mark it, maybe mark the time or what example it is, and shoot me an email, and I'll help you however I can.